Okay guys, so we're just going to do a quick, well it won't be quick, it'll be about 10 minutes, but an example of a motion involving a trig function. So in this case we're going to say we have a particle moving along a line according to the, I don't know, I just put parentheses around that. According to the equation, x of t is equal to t cosine of t plus 2, where t for the time between 0 and 5, and we're going to measure time in seconds and our position in feet. Okay, remember that when we say motion along a line, we're always referring to the x-axis, and the x-axis can have negative numbers on it, right? So although the concepts of physics are similar to this, the actual math involved is a little different. So you could have like a negative distance essentially, because that would mean you're on the negative part of your x-axis. Okay, so just keep that in mind as we go through this problem. So here's my position, and I want to say, okay, what is the velocity? So I want to find, actually let's do speed and direction at t equals 2. Okay, so I'm going to do speed and direction at t equals 2, so I know, because I'm smart, and so are you, that speed and direction means velocity. Okay, so I can use the velocity to tell me the speed and the direction. So, and I also know that my velocity is equal to the derivative of my position. So I'm going to take the derivative of this function. And I know that that has a product in it, right? T cosine of t. So I'm going to have to use the product rule. Okay. And then I just need to put it together like I always do. So u prime times v. So that would be 1 times cosine of t. So I'm done. And then t times negative sine of t would be negative t sine of t. Okay, so that's my product rule. I don't need to worry about the plus 2 because when I take the derivative of 2, it's going to go to 0. So I need to figure out my velocity at 2, essentially, to figure out the answer to this problem. So when I plug in 2 to my function, I'm going to get cosine of t minus, sorry, I'm not plugging in 2. Oopsie daisy. Cosine of 2 minus 2 times sine of 2. Okay, so that is going to equal negative 1.413. So remember, you always need to go to 3 decimal places in this class. Okay, it doesn't matter if you round it or truncate it, just cut it off. You need to go to 3, always, no matter what. Okay, so that's, my velocity is negative 1.413, but the question didn't ask for velocity, it asked for speed. So I need to break this down. So speed is always positive, so I know then that my speed is 1.413 feet per second. Don't forget your units or you will be marked wrong on your test. Feet per second, and I know that my direction is left because my velocity is less than 0. Okay, so I figured out my speed and my direction. So I knew speed and direction meant velocity, and then I broke my answer down into the 2 things the question was asking me for. You need to make sure you're explicitly calling out those 2 things. Okay, so now let's say, let's keep going. Where's my thing? Okay, so now the question's saying, okay, you figured out speed and direction, and I want to know at, I don't know, t equals 4, are you speeding up or slowing down? Okay, now, for this problem, to figure out the change in speed, well, not for this problem, for any sort of motion problem, if you're looking for a change in speed, if you're speeding up or slowing down, you need to compare velocity to acceleration. So luckily, for the first problem, we already figured out the equation for velocity, and now what we're going to need to do is figure out the equation for acceleration. So let's do that. Okay, so I know that, let's just write this down so we don't lose it when I slide my screen up. So v of t is equal to cosine of t minus t sine of t. Okay, so then we also know that acceleration, I updated my iPad and the weird things are, it's very sensitive to my touch all of a sudden. A of t is equal to the derivative of v of t. Okay, so I'm going to have to take the derivative of my velocity, and look, I have a product, so while I'm doing my derivative, I'm going to have to use the product rule. Okay, so let's deal with this term first. So I know that u is negative t, u prime is equal to negative 1, v is sine of t, that's a hot mess, sine of t, v prime is equal to cosine of t. Okay, and then don't forget the derivative of cosine is negative sine, so when I put all this together, I'm going to get negative sine from that first cosine of t, and then I have to put this together to do the derivative of my next term. So negative sine, so u prime times v would be subtracting again, so negative sine of t again. Okay, and then negative t times cosine of t would be negative t cosine of t again. Okay, so if I want to combine my like terms, I'm going to end up with negative 2 sine of t minus t cosine of t. Okay, so that is my acceleration. Now I need to figure out what's happening at 4. Okay, so at 4, so my acceleration at 4 is negative 2 sine of 4 minus 4 cosine of 4. And that is going to equal 4.128 feet per second squared, not meters. Okay, so that's my acceleration at 4. So this is really a of 4, not a of t. Okay, and then I need to compare that answer to what my velocity would be at 4. So I'm going to scroll up a little bit more. So my velocity at 4 would be cosine of 4 minus 4 sine of 4. So that would equal, oh no, where is it? So that would equal 2.373 feet per second. So then to answer the question, this is my acceleration, this is my velocity, they have the same sign, so our particle is speeding up. So it's speeding up because v of t and a of t have the same sign. Okay, so then the last part of this question, that's hypothetical because I'm literally making it up as we go, would be, okay, what is the final, or what's the total distance this particle travels? So if you remember, we're saying that our particle is traveling along a straight line according to t cosine of t plus 2 from 0 to 5 seconds. Okay, so we need to figure out our total distance. So I'm going to scroll back down to the bottom. Okay, so now we are looking for, okay, I don't really know what just happened, but probably didn't affect you guys. So now we are going to look for total distance. Let's do a different color. So remember that our position graph is t cosine of t plus 2. So if you're looking for total distance, the first thing you need to do is figure out all the places your graph is stopped, or your particle is stopped. Okay, because like you walk forward, you stop, you need to figure out that distance. You walk backwards, you stop, you need to figure out that distance. You walk forwards again, you stop, you need to figure out that distance. So it's imperative to figure out all of your stopping points. Okay, if your particle stopped, that means you're stopped when your velocity equals 0. So we know then, because we already figured it out, but of course it's not on the screen so I can't see it, that velocity is cosine of t minus t sine of t. So let's write that down. So velocity is equal to cosine of t minus t sine of t. So we need to figure out all the times where this thing is stopped between 0 and 5. So that means we need to figure out where this is going to equal 0 between 0 and 5. So the easiest way to do this is to look on your graph and to calculate the zeros of your graph. Okay, so I am going to sketch out what this graph looks like for you. Okay, you should also do it in your calculator. So if we have time on the x-axis, velocity on the y-axis, our graph looks something like this. So this is 5 right at the, for velocity. So that's 5 right at the crest of another peak. Okay, I know that my graph hits 0 here and here. So that's when my velocity equals 0. And I use second trace in my calculator to calculate those zeros. Okay, so this first 0 is, hang on a second, something is weird. Sorry. Oh man, I deleted it. But I'm just going to pause this. Okay, I'm back. So this first point is, using the zeros in my calculator, is 0.86, comma 0. And this second point is 3.426, comma 0. So when I set up my little table, we want to plug in the times that are important to us. So the times our particle is starting, stopping, or our velocity equals 0. And then the distance at each of those points. Okay, so we're going to use these times from our velocity graph, but plug them into our position graph. So we know that our particle starts at 0 and ends at 5. So you need to make sure your endpoints are always there, and you want to plug in both of these times. So that's 0.86 and 3.426. Okay, and we're going to plug both those times into our position graph to get how far they're traveling in each of those time intervals. Okay, so I plugged it in, and I know, I'm just going to, that at 0 my particle starts at 2. Okay, if I plug in 0 to t, cosine of 0 is 0, so that would leave me with 2. Okay, at 0.86 my distance is 2.561. Okay, at 3.426 my distance is negative 1.288. Again, you're allowed to have negative distance because it's always revolving on the x-axis, and the x-axis does have negative numbers. And then finally at 5, our distance is 3.4183. Okay, so now we need to look at the distance between these distances. So the distance between 2 and 2.561 is 0.561. Okay, so between 0 seconds and 0.86 seconds when the particle stopped to change direction and it already traveled half a foot, essentially. Okay, so we need to figure out the distance between these two values. Now, there's no like estimation in this class, so you need to actually plug those values into your calculator and see what you are going to get. So I'm going to give you a second to do that. Okay, so when I did that, hopefully you got the same answer. One of us could be wrong if we didn't. 3.849. Okay, remember that you're going from 0 to -1, so you're really taking like the absolute value of -1. Okay, and then you have to go from -1.288 to 3.4 whatever that is, so plug that in also. Okay, so that is 4.7063. And then finally, the last thing you need to do is add up those three numbers to tell you the total distance. Okay? You are going to do that piece of the problem, because I am not. So this was a long example with a lot of different pieces in it, but it also isn't even everything I could ask. Like I could ask for intervals where I'm speeding up or intervals where I'm slowing down. Okay? So you need to make sure that as we work together tomorrow, you're really paying attention to what's happening, because otherwise you're not going to be prepared for your test for this unit. What just happened? Oh no, can I go back?